Alright, so I just go down to the next part. So now the next thing I want to talk about, it's the y-intercept. So just like when we talked about, I'm going to put on the side here, y equals mx plus b. If you remember correctly from this one, the y-intercept, the starting point, was this very last number right here. So starting point or the y-intercept. And that was a lonely number by itself here. Now, with this case, remember that we have actually, let me define what the y-intercept is again. So the y-intercept is where the parabola, I keep messing up. So parabola crosses, and now careful, it's the y-intercept, so it's where it crosses the y-axis. So a really quick sketch of that. So remember that the line going up and down, it's my y-axis. My line going left and right is called the x-axis. So the roots was this x-axis. I wanted to see where the graph touched this horizontal line, this left and right. So when we're talking about crossing the y-axis, the parabola, you could look whatever it's going to look like. It could be something like this. It's a U-shape. I'm just making a positive random cos, not necessarily a process. So my roots are over here where it crosses the x-axis. But now it's going to be slightly different because the y-intercept, I'm looking at the y-axis, is where it crosses this line right here, the one that goes up and down. So this is my y-intercept. Just like we talked about before, it's where it crosses this line, except the roots are where it crosses the x-axis. So we have something else to think about. The y-intercept stays the same. Where does this graph touch this y-axis? So that is the question. So keep in mind that if I have parabola like y is equal to ax squared plus bx plus c, the question is, how can we spot the y-intercept? Because, we can graph this and look at a picture, and that could be easy to spot like we saw above, but what if I'm just given an equation and I have to see the y-intercept? Well, here's a way to think about it. So how can we spot what the y-intercept is? Is there a trick? Don't forget, look at the graph right here. The thing about the y-axis, if you remember, it's exactly where the x value is 0, because we have like 0, 1, 2, 3, 4, then -1, -2, -3. So it's where the x equals 0. So y-intercept is where the x is equal to 0. Okay, so that means it's right here where this line is. So if you think about it using in this line, y equals ax squared plus bx plus c, think about it this way. If x is 0, because it happens exactly here, what does this become? So what is 0 times 0? 0. And what is any number times 0? 0. So like this would cancel out. So let me write it down over here. So y is equal to ax squared plus bx plus c. Oops, bx plus c. So if x is equal to 0, this is 0, this cancels out to 0, this goes away. B times x is equal to 0. So what is what is 0 times any number? 0. So I'm just left with c. Now c doesn't change, it's just a number. So in here, let me scroll down a little bit. So if y is equal to ax squared plus bx plus c, just like what we had before in y equals mx plus b, it turns out it's the same. My c, this lonely number that has no variable, c is our y-intercept. It's this last number, it's the one without a variable. This is the y-intercept, because when it's 0, this goes away, so I'm just left with c. So that's my y-intercept, that's what the y value is.